Before we start today's lessons, let's just take a moment to reflect back on subsets. We talked about sets and their subsets, and subsets are just lists of elements that are members of the universal set here. So go ahead and list all your subsets. Let's now check to see how you did. You start your subsets with putting the empty set. You then go ahead and list all the one elements at a time. You move on to listing sets that have two elements. If there were three elements, you do the same, and actually we include the original set, and then we have a total of 8 subsets. Anytime the original set has 3 elements, the list of subsets will be 8. So now let's take a look at what we've done with compound inequalities. We've solved both the and the or, and we've graphed them as well. These two examples are the and compound inequalities. We mentioned that we could separate these into 2 distinct parts, or we could keep them as one continuous inequality and work the 3 parts. That's the way I like to do it. In this, we notice that the x term has a 2 attached to it. So there are 3 parts: the -2, in the center the x plus 2, and on the right 7. So whatever I do in the center, I will do both on the left and the right. This tells me that x is greater than -4 and x is less than 5. X is greater than -4 and x is less than 5. So if we find -4 on my number line, and we find 5. Now these are our endpoints: -4, which is an open circle, and 5, which is also an open circle. These are the endpoints, and it shades so that all the solutions fall within those 2 endpoints, but it does not include the endpoints of -4 and 5. Second problem, I'm going to have, again, just one inverse operation. It could be a multi-step as well. We could have a variety of ways that we would be isolating our variable, as we've done before. And this tells me that x is greater than 3 and x is less than or equal to 6. Again, I have to have my endpoints. Here's my 3 with an open circle and my 6 with a closed circle, and we see that it's shading in between. It includes 6, does not include 3. The or inequalities list 2 separate inequalities that are graphed on the same number line that extended. Whereas the ands, they overlap. Here they will go in opposite directions. One inverse operation on this first one: x is greater than 2, or make sure you include that word or in your solution. On this second one, we're dividing by 6. X is less than -4. So we have our 2 endpoints once again. I have -4, and I have 2. Open circle at 2 and shading into positive infinity. Open circle at -4 and shading into negative infinity. These are 2 steps. We'll add 3 first. We'll divide by 5, isolating our variable x is greater than 2. Or, because there are 2 parts to this, add 6 for x is less than -4, x is less than -1. So If x were greater than 2, open circle and shading into positive infinity, or x was less than -1 into negative infinity. Those shaded areas tell you what your possible solutions are. Now we're going to move on to another type of notation called interval notation. It helps to describe what's shaded on that number line. There are three basic symbols. We have our parentheses, and we're going to use parentheses with our less than and greater than symbol. We're going to use these brackets when we have a less than or equal to or greater than or equal to symbol. We're going to be using positive infinity and negative infinity. You'll use the parentheses when there's a less than or greater than symbol, which says that the interval endpoints are not part of the solution. They're not included. We'll use the brackets when we have the less than or equal to or greater than or equal to symbol, which says that those interval endpoints are included in the solution. We also have our infinities, which is the positive infinity says that it's going infinitely or forever in the positive direction. I'll put that negative in front of the infinite sign, saying it's going forever in the negative direction. What if I had x is greater than 3? If I decided to graph that on a number line, it would be an open circle and shading into positive infinity. How do I write that in the notation? Well, since it's a greater than symbol, it's a curve. So it's 3, that's the endpoint, and it goes into positive infinity, and there's our interval notation. Let's see a second problem. What if I had x was less than or equal to -2? Representing it on a number line, closed circle, and shading into negative infinity. So when I look at this, I have negative infinity, comma, 2, and a bracket. So we'll get comfortable with this in a very short time. It's not that difficult. We're looking at the less than or greater than using a parentheses. We're using the less than or equal to, greater than or equal to bracket, and then we're using the positive or negative infinity. Here's what it might look like in a question. What is the graph of this? Now they're giving us the interval notation. They're asking us to graph it. Well, we know that the bracket means a closed circle, and we know that a parentheses is an open circle, so I need something at -4. And we need something at 6. Now, we're seeing that this is a closed circle, open circle, and this is an and inequality. And here's the shading. We may be asked to write the inequality that represents this graph, and we have x is less than 6, and x is greater than or equal to -4. Okay. Closed circle, open circle, bracket, parentheses. What is the graph of x is less than or equal to -1, or x is greater than 2? Again, we can graph this. We've already done this before. We'll say this is -1 right here, and here's 2. Closed circle at -1 and shading into negative infinity. Open circle at 2 and shading into positive infinity. This is an OR inequality graph. Now we want to write this in interval notation. Well, for the first part, I see that I have negative infinity, comma, -1 because of the line underneath. This is a bracket. Or we have 2 and a positive infinity. And we'll do some more of these in class.